Prediction of academic performance in college students with bipolar disorder using deep-featured spectral scaling classifier, DFSSC. Abstract: in modern years, the student's performance is analyzed with many difficulties, which is an important problem in all academic institutions. The main idea of this paper is to analyze and evaluate the academic performance of college students with bipolar disorder by applying data mining classification algorithms using Jupyter Notebook, a Python tool. This tool has been generally used as a decision-making tool in terms of the student's academic performance. Due to non-related feature evaluation, the classification accuracy is low. To resolve this problem, we propose to scale out the mutual features to classification performance based on the deep-featured spectral scaling classifier, DFSSC, to predict the result based on the performance of the bipolar student. This implementation progressed with mutual intensive feature selection, MIFS, model to select the features to reduce the dimension. Then selected features are trained with the Softmax Decision Tree Classifier to optimize with Deep Multi-Objective Propagation Network, DMOPN, to categorize the student's performance. Such classification model deals with 13 measures like accuracy, precision, recall, F1 measure, sensitivity, specificity, R-squared, mean absolute error, mean squared error, root mean squared error, TPR, TNR, FPR, and FNR. Therefore, conclusion could be reached that the decision tree classifier is better than that of different algorithms. Keywords: bipolar disorder data prediction, student data analysis, deep learning, features selection, neural network, intensive mutual rate. 1. Introduction. Data mining could be a promising and prospering wilderness in examining information, and the outcome of the investigation has numerous applications. The bipolar student information mining can likewise allude to knowledge discovery from data, KDD. This framework is the machine-driven or helpful extraction of examples addressing information verifiably kept or caught in immense data sets, information from student data sets. Bipolar disorder-based student performance prediction is a developing strategy in data prediction for improving student learning performance. The use of information mining is generally common in training frameworks for analyzing the student learning category. Feature analysis and classification in information mining is an arising field that can be successfully applied in training. The instructive information mining employments a few thoughts and ideas, for example, association rule mining, grouping, and bunching. The information that arises can be utilized to all the more likely comprehend students' advancement rate, student consistency standard, students' progress rate, and the student's prosperity. The information mining framework is urgent and essential to gauge the student's execution improvement. The order calculations can characterize and investigate the student's information set in a precise way. The attributes that may be used for students' academic performance, such as name, college, class tutor name, gender, age, address, family size, parent's status, mother's education, father's education, mother's job, father's job, reason to choose this college, student's guardian, travel time, study time, weekly, number of subjects failed so far, college support, extracurricular, family educational support, paid courses attended, extracurricular activities involves, nursery schools attended, higher education, internet access at home, love relationships, family relationships, free time after college, going out with friends, weekdays, alcohol/smoking, weekends, alcohol/smoking, current health status, number of days absent, CGPA, number of psychological motivation sessions attended, CGPA grade. The main idea of this research paper is to use data mining classification algorithms to study and analyze the academic performance of college students with bipolar disorder. This research paper constitutes 5 sections. Section 1 deals with the introduction, Section 2 enumerates a related work. Section 3 presents the idea and aspects of different classifiers. Section 4 elaborates the data pre-processing. Section 5 explains the implementation of model construction. Section 6 handles results and discussions. The conclusion will be given in Section 7. Students' academic performance in advanced education, is investigated broadly to handle scholarly underachievement, expanded college dropout rates, graduation delays, and other persevering difficulties. 1. In straightforward terms, student performance alludes to the degree of accomplishing present moment and long-haul objectives in education. 2. Nonetheless, academicians measure students' accomplishments according to alternate points of view, going from grade point normal, GPA, to future occupation possibilities. 3. The writing offers an abundance of computational efforts to further develop student execution in schools and colleges, most remarkably those determined by data mining and learning investigation. Procedures 4. The reasonable expectation of student execution empowers the identification of low-performing students. Along these lines, engaging instructors to mediate right on time during the learning cycle and carry out the necessary intercessions. However, productive intercessions are not restricted to student prompting, execution progress observing, shrewd mentoring frameworks advancement, and policy making. 5. This undertaking is supported by computational advances in information mining and learning examination. 6. A new complete study features that around 70% of the checked on work explored student execution expectation utilizing student grades and GPAs. In comparison, just 10% of the investigations reviewed the forecast of student accomplishment utilizing learning results. 3. This whole impelled us to research the work where the learning results are utilized as an intermediary for student scholastic execution. Result-based instruction is a worldview of schooling that spotlights executing and achieving the purported learning results. 7. As a result, student learning results are objectives that action the degree to which students achieve the proposed capabilities, explicitly information, abilities, and qualities, toward the finish of a specific learning measure. In our view, the student results address a more comprehensive measurement for deciding student scholastic accomplishments than simple appraisal grades. This view agrees that the learning results address basic components of student scholarly achievement. 8. Also, eminent accreditation associations, like ABET and ACPSP, utilize the learning results as the structure blocks for surveying the nature of instructive projects. 9. Such significance calls for more exploration endeavors to anticipate the fulfillment of learning results, both at the course and program levels. The absence of systematic reviews exploring the expectation of student execution utilizing student results has roused us to seek after the destinations of this exploration. In an efficient writing survey, i.e., SLR, a bit-by-bit convention is executed to distinguish, select, and assess the integrated investigations to respond to explicit examination questions. 10, 11. 2 related works. M. Silvaguerra et al., 2018, explain that the application of data mining in an academic database is presented, aiming to identify the reasons for student dropouts by preventing failures. Polizu et al., 2019, developing tools to support students and learning in a traditional or online setting is a significant task in today's educational environment. The initial steps towards enabling such technologies using machine learning techniques focused on predicting the student's performance regarding the achieved grades. However, these approaches do not perform as well in predicting poor-performing students. Yao et al., 2019, focus on the prediction of problems and performance rather than revealing the underlying causal relationships. Based on a unique exam data, we extracted the abilities of examinee from HSCE, high school college exam, based on the knowledge of educational experts, but it can not only help educational authorities. Azar, G. et al., 2015, introduces a semi-automated practice that aids in the preliminary diagnosis of the patient's psychological disorder. This is accomplished based on matching the description of a patient's mental health status with the mental illnesses. Bang, S.et al., 2017, developed a quad-phase data mining modeling. Significant diagnostic criteria are selected that are effective for diagnostics for feature observation. Sly et al., 2020, explain that adaptive e-learning can personalize students' learning environment to meet their demands. Numerous studies have indicated that understanding the role of personality in the learning process can facilitate learning. Hence, personality identification in e-learning is a critical issue in education. Zissou et al., 2021, blended learning offers the possibility of individualized teaching for teachers. The combination of flipped classrooms and SPOC is a good way to implement blended learning. Still, few studies have verified the predictability of learning performance in such a scenario to explore individualized teaching. Castaldo et al., 2016, demonstrate mental stress may cause cognitive dysfunctions, cardiovascular disorders, and depression. HRV features were then extracted and analyzed according to the literature using validated software tools. Statistical and data mining analyses were not performed on the extracted HRV features. Kulu et al., 2020, investigation, an experimental methodology was adopted to generate a database. The raw data were pre-processed to fill up missing values, transform values in one form into another, and relevant attribute/variable selection. However, it has a disadvantage in analyzing. Kulu et al., 2021, present a holistic study of student performance prediction. To directly achieve the primary goal of performance prediction, this proposes a general exercise-enhanced recurrent neural network, IJERT, framework by exploring both students' exercising records and the text content of corresponding exercises. 3. Deep Featured Spectral Scaling Classifier. This proposed system predicts the mutual features to classification performance based on the Deep Featured Spectral Scaling Classifier, DFSSC, to predict the result based on the performance of the bipolar student. This implementation progressed with Mutual Intensive Feature Selection, MIFS, model to select the features to reduce the dimension. Then selected features are trained with the Softmax Decision Tree Classifier to optimize with Deep Multi-Objective Propagation Network, DMOPN, to categorize the student's performance. Classification is a process that is used to see. Classification can be a two-venture process comprising of training and testing. In the initial step, a model is developed by investigating the data tuples from training data with attributes. Figure 1 shows the Deep Multi-Objective Propagation Network, DMOPN. For each tuple in the preparing data, the value of the class label attribute is understood. The categorization rule is applied to preparing data to frame the model. In the second step of arrangement, test data is utilized to look at the exactness of the model. Assuming the precision of the model is proper, the model can be utilized to group the unknown information tuples. 3.1 Data Pre-Processing. Initially, the college student dataset is pre-processed with several factors that are considered to have attributes as features. These prompting feature labels are considered non-redundant data with uncovered data filled or non-filled in raw datasets. For this work, recent real-world data is collected from educational institutions to process with a denoise filter algorithm to remove and prepare the dataset. Dataset collected from college students' database are given with the attributes. The above pseudocode prepares to process the original data for noise reduction and the collective student dataset from bipolar disorder and academic performance as features that are ordering the feature index with redundant features. 3.2 Mutual Intensive Feature Selection, MIFS. The intensive form of relational features selection is based on Mutual Intensive Feature Selection, MIFS. This estimates the mutual reaction of differential features related to academic and disorder feature dependencies. Accuracy for considering related features by extracting disorder from the student attributes from learning strategies. Similarity to group the measure by the average mean rate of the threshold value. To improve the clustering performance, this presents an efficient nested integrated feature. The Mutual Intensive Feature Selection, MIFS, groups the relational features by searching the scaling values based on marginal weights. Pseudocode. The suitability of the above pseudocode prevents the infiltration behavior response function from being characterized for discriminating the dimension of sustainability to group these clustering structures to predict data in every iteration, which is to be used in the next iteration for semantic relation. This relevantly measures the semantic similarity closeness of the cluster group. 3.3 Softmax Segmented Decision Tree. The decision nodes are modulated by logical conditions by evaluating FRC-IDS features, marginalized as cluster groups. This creates the logical neurons for training the conditional features in weights to spread based on the selective importance of the feature. Softmax function attains generalization of sigmoid function to a multi-class setting the feature limits by threshold margins. It's popularly used in the final layer of multi-class classification adapted with decision trees. The activation function trains remain the f, x, equals where f, x, remains in integrative margins on SA and STBD. The logistic activation of neuron trained with intraclass logistic transformation feature. Weights, and the training function be iterative till the end the neuron get the closer mean value. It takes a vector of k.frc its real number and then normalizes it into a probability distribution consisting of k probabilities corresponding to the exponentials of the input number from feature limits. Based on the feature limits, the DNN is constructed to train the feature in multi-propagation to fix the weights for multi-propagation. 3.4 Deep Multi-Objective Propagation Network, DMOPN. The marginalized features FRC-IDS are effectively progressed to improve the classification by fed into classifier based on marginal weightage. The hidden layer performs the softmax neural layer to predict the result and accuracy, reducing the computational complexity of the traditional algorithms. The Deep Multi-Objective Propagation Network, DMOPN, finds the closed data points weightage accuracy for predicting relational categories by the high dependencies of bipolar disorder feature weight with higher end support values to categorize the class. By predicting the low rank of students is suggested to motivate for improving the performance of students. Finally, predicted classes projected to multi-data point closeness measure the weightage data points are centralized to neighbor clusters. This will improve the classification accuracy. Multi-data points perception model is a feed-forward classification that maps a set high-quality dataset of appropriate outputs. For results and discussion. The results are processed in Jupyter Notebook, an open-source platform that permits us to create and share documents containing real code, equations, visualizations, and summarized text. It is used for data cleaning, transformation, numerical simulation, statistical modeling, visualization, machine learning, etc. From the above attributes given, the studentanalysis.arf file was created and uploaded into Jupyter Notebook. The above specified attributes influence the academic performance of the students. The results of such classification model deal with 13 measures like accuracy, precision, recall, F1 measure, sensitivity, specificity, estimated with a confusion matrix. Figure 6 analysis of study hours of the students. The present study confirms that an average of 5 hours of study will make the students score good grades. Here, the study also reveals that the study hour does not improve grades, and full focus of the study is needed than the hours. Another promising finding was that the students with extracurricular activities are performing better than those without extracurricular activities. It is worth discussing the psychological motivation sessions that improve students' performance in terms of CGPA revealed by the above results. The performance evaluation is carried out by Windows environment, which is Jupyter's intent. The classification results use parameters to estimate the precision rate, recall rate, classification accuracy, and time complexity to prove the resultant factor. 80859095100010001500200200025000 Quad technique Gaspempamppipelfazerdnstnfsk. The classification accuracy is done by evaluating the sensitivity and specificity analysis by testing the records produced by different methods. The proposed system DFSSC proves the best performance, as shown in Figure 9. The estimation is based on the positive and negative values from the true/false optimized category. Table 3 Performance of classification accuracy. Method/no of. The classification produced by different methods like genetic analysis, GA, technique which has shown 90.6% accuracy, quad technique 91.4%, and SVM produce 94.1% lower accuracy is shown in Table 3. The proposed DFSSC system produces high performance compared to the previous system, up to 96.7%. 7880828486889099496985001000150020002500MFPG Quad technique Gaspempamppipelfazerdnstnfsk performance 8%. Analysis of sensitivity. The sensitivity analysis is shown in Figure 10. The performance of the proposed system PLFazerdn produces higher results than any other method. The existing method SVM produces a low level of 93.4%, and the proposed performance produces a 96.1% sensitivity rate. Table 4 Performance of sensitivity analysis. Table 4 shows the impact of sensitivity rate produced by different methods, in which the proposed system DFSSC produces a higher sensitivity rate than other methods. By definition, the false positive values are correlated with confusion matrix defend with true negative divided with false positive values to defend the classification. The harmonic representation of precision values depends on the specificity of the true positive average mean rate of true positive and false positive values. Table 5 shows the contrast of the specificity rate produced by different methods. Figure 12 Performance of F measure. The F measure defines the sensibility and specificity rate at the mean rate of the absolute error value. The above Figure 12 shows the proposed DFSSC false rate as an F measure value. The accuracy remains the false representation and the lower rate compared to the SVM and previous system. Table 6 demonstrates the contrast of the DFSSC false classification ratio and its appearances show that the suggested process yields less F measure. Figure 13 Performance of time complexity. The time complexity refers to O(n)'s execution rate at the mean time records to be classified at the recommended state. Figure 13 shows the performance of DFSSC time complexity in seconds to classify the result. Table 7 Performance of time complexity. Method/no. Impact of time complexity in seconds. Above Table 6 shows the time performance with execution utilized in different methods. Table 7 shows that the proposed DFSSC method produces 4.1 seconds lower time complexity than other conventional methods. SVM produces 6.3 seconds. 5. Conclusion. The paper presented different prediction models to predict the academic performance of students with bipolar disorder based on their address, study_hours, extra_curriculum, internet_access, family_interaction, drug_use_weekdays, drug_use_weans, leave_log, CGPA, psychological motivation session attended, CGPA_grade? However, this study is limited to the college students of Jamal Mohamed College and a few other college students. From the observation, it is found that the performance of a decision tree classifier is best than that of different algorithms applied in this research. The performance of Deep Multi-Objective Propagation Network, DMOPN, is compared based on the various performance evaluation measures such as accuracy, precision, recall, F1 measure, sensitivity, specificity dependent with true positive rate, true negative rate, false positive rate, and false negative rate. This proposed deep-featured spectral scaling classifier, DFSSC, produces high performance and recommended for educational institutions for the prediction of academic performance in college students affected with bipolar disorder.